You love being slower.
As much as you don't.
I don't even get a chance. I always get.
Alright, guys, work on day one of the routines. Let's see,
Oh, I don't know how to choose it.
Sorry, no. I'll pass it on. I do. You can always tell the girls to sleep when you're like, yes, everyone always knows their turn. How are you supposed to know this?
Yeah. I don't know.
That's why we're reviewing. It's called spiral review. We spiral back and then we do like this. Here. Yeah.
You got that.
Yeah, right. Help me out. It's absent, not a part. On it. And then. I bet somebody remembers the definition. Who remembers? I said he did.
I never read it. I don't remember it.
Logan? Oh. So Logan, what does that mean graphically then? What kind of symmetry does it have?
Origin.
No, origins are one. Just gets
symmetry. So it can't be x-axis because it's x-axis a function.
No.
Okay, so it's y-axis. All right. Somebody else remember odd?
Inverse.
No, not the inverse. It's very similar to what Logan just said.
F of negative x equals negative f of x.
Got it. F of negative x equals negative f of x. And so odd functions have what kind of symmetry?
Origin.
There we go. I would remember odd origin, right? Because it goes start with O. Okay, now based on that, see if you can do the next two problems. For number one, you're going to want to plug in negative x and show that it comes out negative. That's very great. Show that it. Nick, can you get off of that, please?
Yeah.
Yeah, and then just put that equals.
Yeah, you wouldn't respond.
That's what I did. No, I did. I did what you said and everything.
But you're still having it. Okay, so for one, did we do this? Plug in negative x. Negative x. What happens when you cube a negative? Negative, negative. So did that come out to be exactly negative of the original? Because both of the signs switched. Yay, we did it. Any questions on about those steps? And then what'd you guys get for number 2? See? You picture the graphs, a parabola, cosine, and a b. They all have y-axis symmetry. All right, all good? Okay, you put that away. You can grab the 4.1 notes.
Oh, yeah.
Okay, Brian?
Yeah.
Do you have study home?
Yes. 17, 18.
Okay. You want to take this test today?
Sure.
Okay. Kendall, we already talked. Okay, all right. Okay, your current grade in the grade book reflects up to the chapter 3 test, so it doesn't include yesterday's. Okay? So check that. I'll get those back to you on Monday to look at. Hopefully most people have it made up by then. So if you're checking your grades, that's what it is. All right, so we're switching gears now. Yes? Out of 4, I did each part separately, I didn't make that percentage, but 33 out of 40 on each one. So like B minus. All right. So, okay, so are you ready to start trade?
No.
Yes. I'm
Yeah.
always ready for math, Mrs. Markey.
So this section is a little more like application of it. We're not getting into like sine, cosine yet. That'll be next week. So the first thing we're actually going to start with, I know you haven't seen before, so you may not know, but think back like to a yardstick, or sorry, an yardstick. Okay, so you have meter, right? That's one way to measure something. But if you want to be more precise, what unit could you use? So before that, you could use centimeters, right? And then if you want to go even more precise, take millimeters, right? So meter, centimeter, millimeter. Okay, so kind of relate that. With degrees, you know how you have like the little degree symbol? You can actually measure that more precisely. So they subdivide it, so they start with degrees, but then you can divide a degree into minutes, and then minutes can be divided into seconds. So I'll kind of draw you a visual over here. So say you have, like that's 1 degree zoomed in, okay? So each degree could be divided into 60, and we use one little tick mark to denote minutes, so 60 of those. And then the green would represent one of those minutes, right? So then within one of those minutes, you have 60 seconds. So it just gets really, really precise. Am I making sense?
It's like,
So again,
it's like time.
I know. So you use the same units, which can be kind of confusing, right? but we're in a different context. So,
I thought we were in class.
each degree is subdivided into 60 minutes.
Wait, so we're not talking about like time?
No. They're just, the same words are used, I'm sorry for the confusion, it's just what it is.
I like it.
I thought we were talking about.
No, we're talking about how we can more precisely measure an angle.
Time is a construct.
Look, Hayden, look what I drew up here. I drew 1 degree and I subdivided it. Okay. And then each minute is subdivided into 60 seconds. Okay, so over here in the little bubble, we're gonna write our conversions, our new conversions that you get today. So 1 degree. In 1 degree, you have 60 minutes. In 1 minute, how many seconds? 60. And then here's the last one. For now. 1 degree. What if I want to convert degrees all the way to seconds? How many seconds are in 1 degree? 3,600. Good. Because you have 60 of these, right? But within each of those, you have 60 more. So 60 times 60. So 3,600. All right, so that'll take care of the first few problems here. Now, a lot of this lesson today is going to seem maybe like science in a way because you know you do those factor label problems where you have like units up here and you want them to cancel with units down there. It's all right. It'll be all right. It's a very important skill to have. All right. So what you do, we want to convert it, guys, to degrees, minutes, seconds. So the degree part is already taken care of, right? The 37 is a whole number. The 0.425 is what we need to convert. Okay. So this is where those conversions come into play. So if I want to cancel out degrees, I know that in 1 degree, there's 60 minutes. Right, and again, if I have degrees up here, I want degrees down here. So grab your calculators.
Okay.
Take 0.425 times 60. Kendall, what'd you get?
25.5.
And what would the units on that be?
Minutes.
So here's what we have so far. We have 37 degrees, 25 minutes. And yeah, we're gonna, this little part over here needs to be converted now. Take the 0.5 minutes. We want to convert that to seconds. So we know that in 1 minute, there's 60 seconds. And you don't need a calculator for that. 30. So you just put all the underlying parts together. 37 degrees, 25 minutes, 30 seconds. Make sense?
Yeah.
What's going on?
Let's go read the
No,
numbers.
Just writing down.
I'm
Then it would just
exhausted.
be 0 minutes, 0 seconds.
Oh. I think I understand it.
Take this decimal, put it here, convert it. The decimal you get here then is converted as well.
Oh, what's that? Oh,
Are you following or not?
okay, I'm beginning to follow. I'm sorry. I got to bed at 11 last night and I can't think coherently.
Which step are you on?
I'm not accepting.
I just don't want to say.
You're I'm not accepting. I'm not accepting. Not accepting.
Okay. So for the next part, we're gonna go backwards. So this time you're given it in degrees, minutes, seconds. We're gonna convert back. So you take the 24 part, 24 minutes. And you essentially do the same thing, but now we're trying to go to degrees. So our fractions are just gonna be flip-flopped. So in 1 degree, there are 60 minutes. So this time you're trying to get the minutes part to cancel out to end up with degrees. So instead of multiplying by 60, what are you doing this time? Dividing. So go ahead and take 24 divided by 60. How much you get, anybody? 0.4. And what are the units? Degrees, because those cancel out. So far we have 42.4 degrees. Then take this part. And here's where that third conversion comes in. Because if you want to go straight from minutes to second, or sorry, degrees to seconds, or vice versa, 3,600 seconds in 1 degree. So take 36 and divide by 3,600. Anybody? 0.01 degrees. So you're gonna add all the degrees together. 42 degrees plus 0.4 degrees plus 0.01 degrees is 42.41 degrees.
You have to like write out the equation to get your final answer.
No. Doing it for the good of the whole. So, in my other class, Josh, Howe, I think is his name, but his dad's a surveyor, and they use degrees, minutes, seconds, because to measure the land and everything, they need to be very precise. And I can imagine that an architect can't just be like, oh yeah, that's about 30-degree angle, sure. Seems safe, you know. So there's applications to that. All right. We're gonna switch gears a little.
Yeah.
Do you remember the word radian from last year?
Yeah.
So radian is another way to measure an angle. Okay. So it's kind of cool. So if you remember, if you have like a circle, right, you take a sector, which is like a piece of pizza. Okay. Go home tonight and tell your parents you'd like a sector of pizza. Okay. So if you have a radius here, so if you have this radius, and you also have that the arc length has the same length. So like this is A and this is A. The ratio, so this value divided by this value gives you the radian measure. Okay, so like A over A gives you 1, right? So whenever the radius and the arc length are the same, that's what's defined to be 1 radian. Okay? And it's described in our here. So if you have, yeah, so what? Now, I think you'll believe me more once we do this little example. So measure the radius of a circle. All right. We're not actually taking a ruler. We're just going to call it R. Okay. All right. Okay. So we measured R. Then in blue there. Can anybody tell me the distance?
Oh, I'm trying to think. Oh, I have it. I just need to do one of two things in my head. It's because circumference is pi times diameter. Therefore, the radius is half the circumference because the radius is also.
Okay, you got some good thoughts. So instead of writing it as pi times d, you could also
2 pi r.
okay. But I only took half of it, right? I didn't go all the way around. I
So
stopped
it's
here.
pi r.
Yeah. Everybody here? So
That's
circumference.
definitely not the length of the radius. It's pi r.
Ooh, hold on, we're getting. So Paul's concerned. The length of the radius would have been more something like this, right? This would be 1 radian.
That's definitely.
We're going.
Yeah, those definitely aren't the same length. You can tell just by eyeing it.
Right. And so Paul says that if you measure the length around half the circle, that would be half of 2 pi r, right? Which is just going to be pi r. So my question is, what we're getting at then, I'm trying to figure out how many radians are here then. So Paul noted that's definitely not 1 radian, right? It's more than a radian. How many radians exactly? Well, you can take the arc length and divide by the radius, and that's going to give you how many radians. So isn't our arc length pi r in blue? And our radius is just, we're calling it r. So how many radians? Pi. So this is pi. Is that ringing some bells from last year, right? Remember in degrees? Do you remember in degrees how many degrees in a straight line?
Yeah.
I know, like 3-ish.
180. And instead of 180, we can call it
Oh, God, that's not right.
pi radius. Yeah, the unit circle. Right? Remember in the unit circle you would label pi over there?
This kid just sprinted down the hallway.
Yeah.
I know.
Ooh, should I go race him?
Oh well, let's stay in our bubble. We don't need to worry about them. They're animals.
I doubt they were worried about being late.
They spread out.
Okay, you're 6. Who's the problem?
So. Yeah. So 180 degrees is equivalent to pi radians. So to convert from one to the other, so to go from radians to degrees, you multiply by 180 degrees over pi radians.
Uh-huh.
Everything seem all right on there?
We have somebody in this class.
That makes Google, you know.
Does students that are late for class.
So, to convert degrees to radians, you multiply pi radians over 180. And honestly, that's not really something you have to memorize. You should know this for sure. But it really just ends up being a factor label problem again when we get down here.
High rating.
So we're not going to do a ton of these because we'll do more next week, but just working on converting. If you take 150 degrees and you want to convert it to radians, if you have degrees up here, you want degrees down here, so you put 180 on the bottom, put pi radians on the top. Remember doing this? So and honestly, There's a chair. Okay. 150 we're dividing by 180, right?
Yes.
So we can knock a 10 out. And then 15 over 18. 5, 6. And then you just put the pi on it there. So we have 5 pi over 6 radians.
And that's like an interval on the answer.
It is. It's gonna be one of our reference angles. Yep, next week. Are you excited?
I like unit circle because it's the only thing I remember.
Thank you, Mr.
All right. 13 pi over 120. Now that is not one of our reference angles, but we're gonna convert it into this. All right. So I have radians. I want to convert to radians. So I have pi radians down here. And 180 degrees up here. Now conveniently, since these are pretty much textbook kind of exercises, right? You have a pi here. You have pi here, and what happens? Okay, calculate that part. Do 13 times 180. And then divide by 120.
Mm-hmm.
19.5 sounds right. All right.
On the test, would you want it 19.5 or would you want it 19, 30? Or-
Oh, for this, it'd be okay just to go into degrees. Yeah. You'll know if I'll say convert degrees, minutes, seconds. Okay, cool. So we're gonna kind of go back to this picture again. So remember here in blue, that was arc length, right? And that length in blue was equal to pi times r, right? So we had that this, okay? So half of the circumference was pi times r. We showed that earlier. Okay, next. Not right now. Okay, so instead of using the word circumference, because we could measure any little strip of the outside of that circle, right? So instead of using that word, in geometry, what would you call like that little piece in red?
An arc?
Yeah. So the arc length. So let's kind of make a connection. So arc length and then I'm just going to switch order a little bit. R is just R, right? It's the radius. Equals R. And then pi, wasn't that the radian measure we had? But like for this red one, wouldn't this be some other angle? Call it theta. Okay. So R times theta. Kind of see where that's making a connection now?
Uh-huh.
Okay. So what's really important though, remember how I had you tell me what that was in radians? It has to be in radians. So it's as simple as, to find the arc length, you just take the radius times the angle, but it has to be measured in radians. Okay? So I'm going to formally put that down here. You may remember from geometry that the word, or we use S for arc length. So it's given by S equals R. Let me ask you something. Because every year, how do we spell that Greek letter?
Is it THETA?
Did anybody think it was something else? Oh no, it doesn't matter.
I didn't, well, I thought it was beta, not theta with a B.
Did anybody think it was anything but it?
I thought it was theta.
Yeah. So every year,
My wrong answer was wrong.
it's okay. Every year, people think I'm saying, and I don't think it's just me, I think it's just the way the word is, but it's beta and not theta.
Or beta.
So I just want to set the record straight.
Or Heta.
But beta is another Greek letter.
Isn't it that thing that,
Didn't I use it recently? That?
yeah, that's.
Is Theta even a real letter?
When you hold down on the S on the keyboard on Apple phones, and it gives you the
The
beta.
trash singing.
No, I don't, it's not. Okay, so just for the record, it's theta.
The rash.
Okay, you'll get used to all these Greek letters. You're using them math all the time. Okay, so it's theta, and make yourself a note. Make yourself a note that theta must be in radians. Alright, so is anybody getting pizza tonight? On Friday?
I hope I'm getting pizza.
Okay. Well, the next time you get pizza, I challenge you to go home and tell your parents, would you like to know the length of your crust? Okay.
Like, shut up right now. You're not even. Go to your room.
My first class had a similar reaction today, but now you'll be able to. Are you ready? So here's, well, that seemed magical.
Yeah, make sure you.
Okay. So here we go.
For us.
We're actually going to take it a step further. We're going to find the whole perimeter. So we're going to find the crust inside.
We should just like plug up a 6.
Well, that's
Okay. So imagine this pizza slice, right? It's not my best circle, but yeah, it's part of this bigger circle, right? We'll just let it go. This
It's
is
not
the
even
center.
possible.
This is the center. Okay. So what is this distance here? Which is 7 inches. And then we also have this as well, right? Which is, all right. So our goal then, using our formula, is we're going to find the length of the crust.
Staff and students, please pardon this interruption. If you are a Sandy Valley student going back to Sandy Valley for the pep rally, the bus is here. Please report to the bus out in the front lobby. Thank you and have a great day.
Okay. So our crust length, that's our arc length that we're going to be finding, our S formula. And we know, now this is the only thing you might get stuck on at home if you don't have a protractor handy, right? Because you would need to measure, you would need to be able to measure that. And we're told that this slice is 60 degrees intercepted.
I can't wait to do this.
I can.
Okay. Now, should I, don't write this down yet. Is this gonna be, I'm just gonna do this, right? I'm done. It's 420 inches.
Not at all.
Clearly.
Right, cute. Oops. Yeah, well, yeah. But arc length would give me 420 inches, right?
Yes.
That's a big one.
That's great. That's thick.
Do you think that's true?
What goes, why
Wait.
did you scribble out the exponent?
Don't write this down.
Dang
What
it.
did I do wrong? Okay, can you convert 60 degrees for me, please?
Yeah.
60 degrees.
To radians.
Oh. I
You got it sitting in your head. So you can. This step.
Oh, this, oh.
equal to or E. I'm having a rough day today. I'm more of a
I really understand.
Alright,
And you don't want one.
Bailey, what'd you get?
No, 1/3 pi.
Okay, so pi thirds radians, right? So now we have our pi thirds radians, that's this number here, and we need to multiply by
No.
7. Alright, so 7 times pi thirds would just be 7 pi thirds. And then don't forget, we wanted the perimeter, right? So that's your crust length. Okay, that's your crust. Which I'm just curious, as a decimal, what about is that 7 pi divided by 3? Can you do that real quick?
7.33.
That seems more reasonable. 7.33. Very rough. Alright, so the perimeter then is 7 plus 7 plus 7 pi thirds. And because this is a real life problem, a decimal would make more sense. So go ahead and add that number you just told me plus the 14. 21 point, say it again.
330.
Okay. Inches, very good. Alright, awesome. Alright, so if you do that, please let me know how it goes. If there's anything.
Don't worry.
Alright, runners.
Maybe you can go back.
Who are the runners in here, remind me?
I'm not the only one.
If you don't run.
Okay, so we have a scenario. We're just looking at a portion of the track, okay? The circular portion at the end, okay? So it says the running lanes at a racetrack are both 1 meter wide, which is our meter stick here, okay? And the inside radius of lane 1 is 33, inside radius of lane 2 is 34. So let's draw a picture so we can understand what the inside radius means. So go ahead and draw 3 semicircles, concentric. So this would be like the end of the track. Of course, then you'd have the straight part, but we're only looking around the turn. And so this inside lane is going to be what we're calling lane 1, and then lane 2. No. Okay. So.
Sorry. Do what?
I don't know. Okay. Do you see lane 1?
Yes.
Do you see how you have the inner and then the outer? Yeah. So that means from the center here, that distance is 33 meters.
Can I do it?
Then
You write the stuff down.
center to lane 2 inside
Just write the
is
stuff down.
34 meters. Okay, so our goal, it says, how much longer is lane 2 than lane 1 around this one turn? So I want to know how much longer is the purple than whatever you used yet, orange. How much longer is the purple than the orange? So this is an application of our arc length, right? The purple is an arc length, the orange is an arc length. So my question is, we have the radii easily, yes, 33 and 34. What's the angle that it's going through? Right? Why?
Because it's a semicircle, like half of it.
Yeah, it's what we did earlier here, right? So that's pi. So let's go for lane. So lane 2. We'll start with the purple since that's the longer one. So the length of lane 2 would be our 34 times pi, and pi is already in radians, so that's good to go. So S equals 34 pi meters. And then lane 1 Aiden, what's lane 1? Length. What's the radius?
33.
Okay.
So 33 pi.
I'm sorry, it looks like no.
Are you okay?
I get it now. I was.
So what
I,
we're doing?
I associated the one with the purple line and the two with the green line.
So, and again, this is pi. Okay. So what's the difference then? How much longer is 2 than 1? Just pi. Beautiful, right? You just subtract 34 pi minus 33 pi. So lane 2. Lane 2 is pi meters longer. If you think about it, would that be true between, I know, obviously there's more than 2 lanes, right? How many lanes are there? 8. So like between lane 1 and 3 then, 1 and 4. So you go to your coach and you tell them that too. Okay. All good math things. All right, last topic. So who drives in here? Anybody? Okay. Okay, great to have.
Me too.
Oh, God.
Give me your average speed in the city.
If I'm paying attention, to the speed limit, but if I'm not paying attention, 50. I go really fast.
Okay.
And then my parents start yelling, and then I go like 20, but I drop fast. But because I don't remember that, I forget that I have my foot on the gas, and so I just keep pressing down the gas, and we're just accelerating, and I'm just driving fast.
Okay, so if I just really wanted the number 50, go again. 35, your average speed in the city, like 40.
If I'm going down a 35 road, there's no way I'm going 35. Sorry.
I was.
Alright, so Peyton is going 50 miles per hour, right? If you have to explain that to somebody, what would you say? In somebody well, that's not. What does that actually mean? You had to explain it to a person.
If she were to travel 1 mile.
If she were to travel what? Think of the unit.
Travel 55 miles.
There. Okay. So in 1 hour she goes, and that's linearly, right? Like measuring distance normally, yes? Okay? Now, something,
She does.
but what if, so that's what's called linear speed, because you could literally measure it in a line. But what if you wanted to know, like, okay, when she's going 50 or 55 miles per hour, how fast are her wheels going angularly? So revolutions, how many revs per minute? In our case now, we can also convert to like radians. How many radians is she going through per second or something like that? Okay.
More than you should.
So, go back to the very first slide. I'm gonna add 2 conversions to your little bubble.
Better at going, especially on tubs.
No, it's hard when you got like.
I always go over. Okay,
Ready? Okay, we're talking circles here. Because our typically wheels or belts or something are spinning, right? So around a full circle, guys, how many radians around a full circle? Ty? TJ? 2 what? 2 pi, right? Because we've already talked about them many times that half the circle is pi, the whole circle is 2 pi. All right, so your next conversion to add is that you have 2 pi radians in 1 revolution. So 2 pi radians, 1 rev. And then the second one, I'm gonna have you look at this real quick. Remember when we were defining radian earlier? And for every 1 radian, that means you have a radius worth of length in your arc, right? So it's gonna seem kind of funny the way we write it, but so for every radian, so for every 1 radian, you have a radius length. So, and I'm not gonna put 1 radius, because your radius will change. So I'm just gonna put one radian for every radius length. Yes. So these should be the only new conversions. Everything else you'll know, like feet to inches to feet to miles and all that we're gonna do in a second. All right, so let's do this last problem. Okay, so we have 36-inch diameter wheels that are rotating at 630 revolutions per minute. Our goal is to convert that into how fast linearly this car is traveling in miles per hour. So you always want to start with what you're given, 630 revs per 1 minute. Okay, our unit of time, what are we trying to get to? What unit in time? Hours. So, what shall I put where? So minutes are gone. We already have half of the unit for our goal. We already have hours on the bottom. All right, and then here's where some of the new conversions come in. The only conversion we had with revs was revs to radians, right? So 1 rev, how many radians again? Okay, so if I put revs down here, so 1 rev, 2 pi radians. So we have revs going away here. Last box. Okay, and then the new conversion. For every 1 radian, there's a radius length, right? What's the radius of these tires? 18.
Sorry.
Okay. So for every radian, there's 18 inches being covered. So now we have radians going away. And what are we trying to get to lengthwise? Miles. Okay. Inches in a foot. All right, and who knows this one? You should. Now I would highly recommend, if you don't know this conversion by now, you should know. Okay, 5,280 feet in 1 mile.
I love the standard system, yes, I do.
I love the standard system. How about you?
You know what else I love? I also love cutting off my head so I can pull out my own spinal cord and swallow it.
Stop.
I didn't mean to put one in there.
That's what I was doing. I like how we call ours the speakers.
Okay. So notice, we have achieved miles on the top, hours on the bottom. Now, when you type this in, you can't type it all in one swoop. You're going to need parentheses around the top, parentheses around the bottom. Go ahead and try to punch it in. Or you can do it in steps, either way. That looks good. Does it seem reasonable? That it would go in that fast?
This is how fast I go under parking lot. This is my school zone. This is my school zone. That's why I go to school. My rules. Okay. Once more time I walk out.
Yeah, part of it was like stuff.
I don't understand why
I have to go really slow.
Okay, guys, look up here. When you're typing it in, here's what I meant by the parentheses. Parentheses around the top, parentheses around the bottom. Some of you were getting like wild numbers, right? Like 800 miles per hour.
That's how I drive on 21.
Okay? So, about 67 miles per hour. Okay. So, we're gonna practice one more of those today. So you can put your notes, or you can leave your notes out for the conversions. Okay, there's 2 problems, but I think we're just gonna do number 2 since we have about 10 minutes. So I'm gonna give it to you with number 2 facing up. Practice.
Thank you, Mr.
Wait, how many times did you have to say? Okay.
With your pod. With your pod, you're doing number 2 only. You You have 6 minutes.
No wonder.
One more thing.
No more times.
Answers. Give your answers in terms of pi.
I need a.
With their eye. Work together, Paul.
What is the angular?
How much we talk about the
That's why we have to have locks on our things, but
Is that
all right, let's go.
Going right in my ear, ASMR moment.
Antisocial.
I always think I understand where
I can't stand ASMR. It's so irritating. I mean, how does anyone find that feeling pleasant? So
Put one started
irritating.
and started on
you put one.
I don't know what to do. What did you?
Always start with what you get. 135.
Why should I care about the Amazon paradise?
That's the call.
Is that going on top?
Right after.
Radius there.
You ready?